Well, we'll look at a couple of statistical functions we can do with data. Now, for some of these, we need to do a little bit of work ahead of time, or you could consider these some of the statistical functions, but we've done them already. So I will need a mean, so I'll take an average and highlight all these data. These are chick weights in for different feeds. We're going to end up using these for an analysis of variance later, but right now I can get their average, I can get their standard deviation. Let's see, I think I'm spelling that wrong, but we'll see pretty quickly here. So I think I needed an N in there. No, I guess I didn't. Okay, so there's standard deviation. And then to get the count, or N, I simply say that count, and it counts all the values here that have numbers in them, or all the cells that have numbers in them. And so there we go, we needed that. So now if I want to make a confidence interval out of all that, I have 71 data, so I can use a Z confidence interval. And so here's confidence width, and that's what it'll return, is just that width on there. So just to show you what's going on here, let's do an insert function, and we go down to confidence, and we want confidence.norm. That's assuming a normal distribution. We need an alpha, so we'll use our 0.05. Notice we need the standard deviation, so that's where I come over here and get that standard deviation. And we need the size, or N, and so we come over here and get N, and so that is our command, equals confidence.norm, and our three different parameters we need, and we see the result. So the width of our confidence interval is 18.16, and we can get the left and the right if we wish. So here's left and the right, or the right, how about that? Okay, and left, well, that's just equal to our mean minus that width, and so we have that one, and then our right is equal to that mean plus our confidence interval width. And so there I see the confidence interval goes from somewhere around 243 up to 279. Okay, so if we have a small sample, so this is just the horse bean feed for the chick weights, excuse me, then we need a t-test instead, or a t-confidence interval, actually, I guess, since that's what we're doing, is confidence interval. Well, it's done the same way. We still need our mean, our standard deviation, and our N. So now, though N is small, it's just 10. Again, if I want to go looking for the function, I can come in here, and it's confidence T. So we have that, but we need the same things. We need our alpha, so if I want the 95% confidence interval, I can do that. Standard deviation, it's right there, and my sample size, right there, 10, and I say OK. And now my width is 27.6, and again I could get the left and the right simply by subtracting and adding respectively from the mean there, and so that's our T, small sample T confidence interval. Well, how about a z-test? So here, suppose we have this 80 mu equals 240, HA, mu is not equal to 240, so we have a two-sided test. Then we can actually just run a z-test, so insert function, and if I go all the way to the bottom, I get to a z-test, and we need our data, makes sense. So I highlight all those data. So I have that. Then I need our hypothesis, our mu. So not the average, not the median, but, or sorry, not the mean, but the mu here, and of our hypothesis test. And then now the sigma, actually, we don't want to use that. Let's see. Notice it says the standard deviation of the population. Well, we don't know the standard deviation of the population, but it says if omitted, the standard deviation of the given sample is used. Well, that's how we run these things, and so we want to stop there with just mu. So we just need our data and our hypothesized mean. We can see our result here. We say OK, and we get a two-sided p-value of 0.01, which makes sense. We are definitely outside our 95% confidence interval, so I would have expected a p-value less than 0.05. I don't know about 0.01, I just know I expected one less than 0.05. Now, notice if I wanted to do a one-sided, they didn't have an option for that, and so here to get a one-sided, I would actually simply divide this two-sided by 2. And you need to be a little careful of that your one-sided makes sense. So here, if I did greater than 240, since my data are greater than 240, that's a reasonable hypothesis test to run and to take this p-value and divide it by 2. If this had been less than 240, well, my data wouldn't have supported that at all, since they were bigger than the 240, and so if it was one-sided with a less than, I wouldn't even bother running it. I would just definitely stick with the null hypothesis. I would fail to reject in that case. Now, back to our small sample. If I wanted to do a similar kind of thing with this small sample, so mean of 160 and hypothesized mu of 190, and I wanted to check that two-sided test, that hypothesis test. Well, actually, unfortunately, I'm out of luck as far as just a canned function. So if I go to insert, it starts looking good. I say function, I scroll down here, and I find a t-test somewhere, t-test, or there's also t.test. Either one is fine. But notice, so data 1 required, great. I can go up here and put that in, and so there's my small sample. But now notice data 2. Well, unfortunately, it says it's required. So I don't really have a way to do this single sample t-test, testing against a mean, other than our, so I'll cancel that, other than our usual method. So what's that usual method? Well, I need to take our mean and our standard deviation. So if I come down here and I say, okay, here's my t variable, right? So what do I need? I need my data mean. Okay, so I need my data. Whoops, I need to put in an equal sign. So I need my data, and then minus my hypothesized mean. Okay, so I had that, but then remember that's over our standard error, and so divided by, and our standard error is just our standard deviation divided by the square root that. Okay, so there is our t-value at negative 2.439. And so then to get our two-sided p-value, here I need to insert a t statistic, well, a t variable. So down here I need to come down and find the t distribution. So there's t dot dist and there's t dist somewhere, I think. Dot and t dist. Well, I could be wrong. Let's see. ed. There it is. T dist. So either one will work. And so the number, that's our t value. Okay, we have that. Degrees of freedom. Now, I didn't put that anywhere, so I can just look and see that that's 9. And then cumulative, we want to use cumulative, so 1 for that, and we say OK, and there is our two-sided p-value, and again, it's, I picked numbers that I would get something statistically significant, less than 0.05, and yeah, it's around 0.02, and again, that's kind of what I would expect. If I went up here on my confidence interval, I'd get to 187.6. I went with 190, and so if we're going to do a single t-test like this, we have to pretty much do it by hand. So now we can get back to our t-test for two populations, and even if you have a large sample, this is what you want to do, is use a t-test, and if you're going to do it in Excel or some other spreadsheet. So here I have 2 columns of data, chick weights for the horse bean, chick weights for the linseed, and I would like to do my t-test for this. So here's my t-test, and so I'll go back to that, insert that function, come down here, find the t's, and there's our t-test. And remember, we needed our 2 data sets, so here's our first data set, and here's our second data set. So we have that. Now our mode, notice that's how many tails, so let's go with a 2-tailed test again. And type, now this is nice. I don't know why they don't say it here, but type 1 is paired and type 2 is unpaired, and so we want a type 2. Notice you get a number of 0.008 here. If I do a type 1, I get an error. Now why would that be? Well, because type 1 is trying to do paired, and these can't possibly be paired because I'm missing, I don't have data here. And so that it actually was at least smart enough to know in that case that if I had said paired, I was being a little silly, because it wouldn't make sense in that case. Even if I thought for some reason I should have paired data, it doesn't. If you can't have both a before and after, or some sort of pairing for each case, so I don't get the same number of data in each column, how could they possibly be paired? Okay, so I hit OK, and there is my two-sided test done that easily with Excel.